Your engine is a precision machine, and most of them don't fail from age. They fail from neglect. In fact, nearly 60% of early engine failures come from simple maintenance mistakes. It doesn't matter if you drive a small sedan or a full-size truck. Do this right, and your engine can last hundreds of thousands of miles longer. Today, I'm breaking down 15 must-know engine habits anyone can follow. Let's start. Number 15. Modern engine warm-up protocols. The automotive industry has evolved significantly over the past 2 decades. Today's engines utilize advanced materials and tighter tolerances than their predecessors, which fundamentally changes how we should approach warm-up procedures. Extended idling before driving actually creates more problems than it solves. When an engine idles stationary, certain components warm unevenly. The combustion chamber heats up while transmission fluid, differential oil, and wheel bearings remain cold. The optimal approach? Start your engine and allow 20 to 30 seconds for initial oil circulation. Then drive normally, avoiding aggressive acceleration for the first few miles. This method warms all drivetrain components simultaneously and reaches operating temperature more efficiently. During cold weather, fuel combustion is less complete at idle. Unburned fuel can contaminate your oil, accelerating wear on cylinder walls and piston rings. By driving gently from the start, you actually protect your engine better than sitting in the driveway. This adjustment alone can prevent thousands of dollars in long-term engine wear. Number 14. Oil service schedules. Engine oil serves 3 critical functions: lubrication, cooling, and contamination removal. Over time, the oil's chemical composition breaks down, reducing its effectiveness in all 3 areas. Many drivers rely on appearance to judge oil condition. This is fundamentally flawed. Oil can appear relatively clear while its additive package has completely degraded. The additives that prevent corrosion, neutralize acids, and suspend particles deteriorate with heat cycles and time, not just mileage. Industry standard recommendation: follow your manufacturer's specified interval, typically between 5,000 and 7,500 miles for conventional oil, or 7,500 to 10,000 miles for full synthetic. Severe driving conditions, including frequent short trips, extreme temperatures, or towing, require more frequent changes. Your oil filter has finite capacity. Once saturated with contaminants, it bypasses unfiltered oil directly to your engine. Regular oil changes prevent this scenario and maintain proper lubrication throughout the system. Consider oil changes as preventive insurance. The cost is minimal compared to the catastrophic damage that occurs when lubrication fails. Number 13. Mass airflow sensor. The mass airflow sensor is a precision instrument that measures incoming air volume, allowing your engine's computer to calculate optimal fuel delivery. This component directly influences fuel economy, emissions, and engine performance. Environmental contaminants gradually coat the sensor's delicate elements. Even a thin film disrupts the readings, causing the engine control unit to miscalculate the air-fuel mixture. Symptoms include decreased fuel efficiency, hesitation during acceleration, and irregular idle quality. Maintenance procedure: every 15,000 miles, remove the sensor and clean it with MAF-specific cleaner spray. These cleaners are formulated to evaporate completely without leaving residue. Never use standard contact cleaners or touch the sensor elements physically, as they're extremely fragile. This 5-minute procedure restores accurate airflow readings and optimizes engine management. It's one of the highest return on investment maintenance tasks available.
Number 12. Replace engine air filters. Your engine requires approximately 9,000 gallons of air for every gallon of fuel burned. The air filter is the only barrier preventing abrasive particles from entering your combustion chambers. A restricted air filter creates multiple problems. First, reduced airflow leans out the air-fuel mixture, forcing the engine to work harder for the same power output. Second, the engine control system compensates by adjusting fuel delivery, which reduces efficiency. Third, in severe cases, the filter can collapse, allowing unfiltered air into the engine. Replacement schedule: inspect every 12,000 miles and replace as needed, typically every 15,000 to 30,000 miles, depending on driving environment. If you regularly drive on unpaved roads or in dusty conditions, have this interval. A clean air filter improves throttle response, increases fuel economy by up to 10%, and protects internal engine components from accelerated wear. The part costs less than most oil changes and takes minutes to replace. Number 11. Maintain your cooling system properly. Your cooling system operates under extreme conditions, cycling between ambient temperature and over 200 degrees Fahrenheit multiple times daily. Coolant is an engineered fluid that prevents freezing, inhibits corrosion, lubricates water pump seals, and transfers heat efficiently. These properties degrade over time. As coolant ages, its pH balance shifts, becoming acidic. This corrodes aluminum components, attacks rubber hoses, and creates deposits that restrict flow through narrow passages. Eventually, the cooling system fails to regulate temperature effectively. Service interval. Most manufacturers recommend coolant replacement every 30,000 to 50,000 miles, though some extended life formulations last up to 100,000 miles. Always verify your specific vehicle requirements. During service, the entire system should be drained and flushed with clean water to remove accumulated sediment. Fresh coolant is then added according to manufacturer specifications. This preserves your radiator, heater core, and most importantly, prevents overheating that can warp cylinder heads or damage head gaskets. A cooling system failure can destroy an engine in minutes. Regular maintenance prevents this catastrophic scenario. Number 10. Monitor thermostat function. The thermostat is a temperature-activated valve that regulates coolant flow. When functioning correctly, it maintains your engine within its optimal operating temperature range, typically between 195 and 220 degrees Fahrenheit. Thermostat failures occur in two ways. A stuck closed thermostat blocks coolant circulation, causing rapid overheating. A stuck open thermostat allows constant coolant flow, preventing the engine from reaching proper operating temperature. Both conditions cause problems. Overheating can warp metal components and breach gasket seals. Running too cool increases fuel consumption, accelerates oil contamination, and reduces cabin heater effectiveness. Warning signs: temperature gauge fluctuations, extended warm-up periods, overheating in traffic, or poor heater performance all indicate potential thermostat issues. This component typically costs between $15 and $40, making it one of the most economical replacements in automotive maintenance. Given the potential for severe engine damage from failure, replacing thermostats proactively at 60,000-mile intervals is sound preventive practice. Number 9. Upgrade to synthetic lubricants. Synthetic oil is chemically engineered rather than refined from crude petroleum. This manufacturing process creates uniform molecular structures that outperform conventional oil in multiple ways. Synthetic lubricants maintain viscosity across wider temperature ranges, resist thermal breakdown better, contain fewer impurities, and provide superior protection during cold starts. These properties translate to extended drain intervals, reduced engine wear, and improved fuel economy. Cost-benefit analysis. While synthetic oil costs more per change, extended drain intervals often make the total cost comparable to conventional oil. The real value comes from reduced engine wear and better protection during severe operating conditions. Modern turbocharged engines particularly benefit from synthetic oil due to extreme heat generated in the turbocharger bearings. Many manufacturers now specify synthetic oil as the only approved lubricant. Verify your owner's manual for compatibility and specifications. Most vehicles manufactured after 2010 can safely use synthetic oil, though some older engines with worn seals may experience minor leakage issues. Number 8. Service transmission fluid. Automatic transmissions contain hundreds of precisely machined components operating within thousandths of an inch tolerances. Transmission fluid lubricates these parts, transfers hydraulic pressure for gear changes, and cools the entire assembly. Unlike engine oil, transmission fluid operates in a semi-sealed environment. However, it still degrades from heat, friction, and contamination. Oxidized fluid loses its friction-modifying properties, leading to harsh shifts, slippage, and eventual transmission failure. Service recommendation. Most manufacturers suggest transmission service every 30,000 to 60,000 miles. Vehicles subjected to towing, mountain driving, or frequent stop-and-go traffic should follow the lower end of this range. During service, old fluid is removed and replaced with fresh fluid meeting manufacturer specifications. Some transmissions also require filter replacement. This maintenance dramatically extends transmission life and maintains smooth shift quality. Transmission rebuilds cost thousands of dollars. Regular fluid service is inexpensive insurance against this major repair. Number 7. Inspect and replace serpentine belts. A single serpentine belt typically drives your alternator, power steering pump, water pump, and air conditioning compressor. Belt failure means immediate loss of these systems, often resulting in engine overheating and battery discharge. Belts deteriorate from heat exposure, ozone, and flexing stress. Cracks develop on the inner ribs, edges fray, and the rubber compound hardens. These changes occur gradually and may not be visible during casual inspection. Inspection schedule. Examine your belt every 30,000 miles for cracks, glazing, or missing chunks. Most belts should be replaced between 60,000 and 100,000 miles, regardless of appearance. Belt replacement is straightforward on most vehicles and prevents roadside breakdowns. Some engines use the serpentine belt to drive the water pump. If this belt fails while driving, the engine can overheat within minutes, potentially causing severe damage. Carry a spare belt in your vehicle if you frequently drive in remote areas. The small investment provides peace of mind. Number 6. Avoid excessive engine revving. Engine speed directly correlates with internal stress levels. Higher RPMs increase combustion pressure, generate more heat, and accelerate wear on moving components. Unnecessary revving, particularly when the engine is cold, forces parts to move at high speed without adequate lubrication. Oil requires several minutes to reach full operating temperature and achieve optimal viscosity. High RPM operation during this warm-up period accelerates wear on bearings, cylinder walls, and valve train components. Best practice. Allow engine speed to rise naturally during normal driving. Modern engines develop adequate power at moderate RPM levels. Avoid rapid acceleration from stops and resist the urge to rev the engine unnecessarily. Automatic transmissions are programmed with shift points that balance performance and longevity. Manual transmission drivers should shift before reaching the red line, typically keeping RPMs below 4,000 during normal driving. Smooth, progressive throttle inputs not only protect your engine, but also improve fuel economy and reduce emissions. Number 5. Replace spark plugs at specified intervals. Spark plugs ignite the air-fuel mixture in each cylinder, creating the combustion that powers your engine. Each plug fires thousands of times per minute, gradually eroding the electrodes and widening the gap. As spark plugs wear, the voltage required for ignition increases. Eventually, misfires occur, particularly under load or during cold starts. Misfires reduce power, increase fuel consumption, and can damage the catalytic converter. Replacement intervals. Conventional copper plugs typically last 30,000 miles. Platinum plugs extend this to 60,000 miles. Iridium plugs can function for 100,000 miles. Always follow your manufacturer's recommendations. Worn spark plugs also force the ignition system to work harder, potentially shortening coil life. Replacing plugs on schedule prevents these secondary failures and maintains optimal combustion efficiency. This maintenance task requires basic tools and mechanical aptitude. The cost is minimal compared to the fuel waste and potential damage from ignoring worn plugs. Number 4. Ensure proper air filtration. Every engine requires clean air for efficient combustion. The air filter captures particulate matter before it enters the intake system, protecting sensitive components from abrasive damage. A saturated air filter restricts flow, reducing available oxygen for combustion. The engine control system responds by reducing power output and adjusting fuel delivery. This results in sluggish acceleration, reduced fuel economy, and increased emissions. Maintenance schedule. Inspect the air filter every 12,000 miles. Replace when visibly dirty or at 15,000 to 30,000 mile intervals, depending on environmental conditions.
Desert environments or areas with high pollen counts require more frequent replacement. Some vehicles use reusable filters that can be cleaned and re-oiled. Follow the manufacturer's cleaning procedure carefully to maintain filtration efficiency. Clean air filtration protects your engine's internal components and maintains optimal performance. The minimal cost makes this one of the most cost-effective maintenance items. Number 3. Practice smooth acceleration. Aggressive throttle inputs stress multiple vehicle systems simultaneously. Wide-open throttle operation forces maximum fuel delivery, peak combustion pressure, and highest component loading. While engines are designed to handle occasional full-throttle acceleration, repeated hard launches accelerate wear throughout the drivetrain. Transmission clutches slip more, differential gears experience higher loads, and engine mounts deteriorate faster. Driving technique. Apply throttle progressively, allowing the transmission to shift smoothly through gears. Anticipate traffic conditions to minimize hard braking followed by aggressive acceleration. Maintain steady speeds when possible. Turbocharged engines require special consideration. After hard driving, allow the engine to idle for 30 to 60 seconds before shutdown. This lets the turbocharger cool gradually, preventing oil coking in the bearing surfaces. Smooth driving habits improve fuel economy by 15 to 30%, reduce maintenance costs, and extend component life throughout your vehicle. Number 2. Perform throttle body maintenance. The throttle body controls airflow into your engine. Over time, oil vapor and combustion byproducts create deposits on the throttle plate and bore. These deposits disrupt airflow patterns and prevent the throttle plate from closing completely. Symptoms include irregular idle speed, stalling when coming to a stop, and reduced throttle response. In severe cases, the check engine light may illuminate due to incorrect idle air control. Cleaning procedure. Remove the air intake duct to access the throttle body. Using throttle body cleaner and a soft cloth, carefully remove deposits from the throttle plate and surrounding bore. Avoid forcing the throttle plate, as this can damage the electronic positioning sensor. After cleaning, some vehicles require a throttle position relearn procedure. This process varies by manufacturer, but typically involves a specific sequence of key and pedal positions that allow the engine control unit to recalibrate idle settings. Regular throttle body maintenance, typically every 30,000 miles, maintains smooth idle quality and optimal engine response. Number 1. Intake system carbon cleaning. Modern direct injection engines spray fuel directly into the combustion chamber, bypassing the intake valves. This improves efficiency but creates an unintended consequence. Carbon deposits accumulate on intake valve surfaces. These deposits restrict airflow into the cylinders, disrupt fuel atomization, and create hotspots that can cause pre-ignition. Over time, performance degrades, fuel economy decreases, and rough idle develops. Professional service. Intake carbon cleaning typically requires specialized equipment that introduces cleaning chemicals through the intake manifold or directly into the combustion chambers. Some technicians use walnut shell blasting to mechanically remove heavy deposits. Using top-tier gasoline with enhanced detergent packages helps minimize deposit formation. Some manufacturers recommend periodic Italian tune-ups, sustained high RPM operation that helps burn off light deposits. This service, performed every 30,000 to 50,000 miles, restores lost power and efficiency. It's particularly important for turbocharged direct injection engines that operate at higher temperatures and pressures. Engine longevity depends on consistent, informed maintenance practices. These 15 procedures form a comprehensive approach to preserving your vehicle's most expensive component. None of these tasks require specialized training or professional shop equipment. They're practical, achievable steps that any driver can implement. The investment of time and modest expense prevents catastrophic failures that cost exponentially more to repair. If you found this information valuable, please subscribe for additional automotive maintenance guidance. Thank you for watching, and I'll see you in the next one.